Welcome to D Technology. As an ANSYS channel partner, we provide simulation capabilities in the areas of fluid dynamics, structural mechanics, electromagnetics, and systems and multiphysics. D seldom supports ANSYS software in the central United States. We also provide consulting and training for the entire ANSYS software suite. Our mission is to help clients maximize their utilization of ANSYS software to the highest degree possible.
This is workshop 4A from DoD's two-day nonlinear course. We have an assembly here. It's an axisymmetric assembly. So you can visualize what the geometry looks like in 3D by looking at this axis of symmetry. So the y-axis is the axis of symmetry. So all these parts, these surfaces, you need to spin about that axis of symmetry, the y-axis, to visualize the 3D geometry. And the main thing we're interested in is what's going on here. Here you can see the light gray parts are both rubber, and you have quite a bit of interference between this rubber part and this metal. And the physics of the problem is we want to put a kind of an annular spring in this slot right here, such that we have a force in the negative x direction that's going to tend to push this rubber part into the metal part, because we want a fluid seal. We want to make sure that particles in fluid don't get from one side, this area here, to the other side. So we're going to solve the model in two steps. In the first step, we'll resolve the interference, and in the second step, we'll apply this force of 100 pounds in the inward radial direction. So let's go ahead and plot what the results look like. So in the first step, we'll resolve the interference, and then in the second step, we apply the inward radial force on this region in here. So let's zoom in here a little bit. So again, we're getting rid of the interference, and then when we hit this time equal 1, then we kind of squash the rubber part, and we get the point on the part becomes kind of flat. You kind of see how that occurs. And of primary interest is in contact. We want to know what the contact pressure is right there. So that's the contact pressure in psi. Okay, let's take a look at the material properties and how we did the curve fitting here. So in this case, we had rubber. We named the material rubber, and we had uniaxial test data, as you can see here. So here's a table, and then we're plotting it. We had biaxial test data, shear test data, and yeah, it looks like just those three sets of test data. So we just copy and paste them into the engineering data module. Then we chose Mooney-Rivlin 2-point model, and here are the constants. So just so we can see how that works, I'm going to delete that material. And let's go over here to our material toolbox. So these are all of the materials that are available, that are for model and hyperelastic, and we use this 2-point Mooney-Rivlin. So the way the process works is you read the test data in, then you choose the model you want to use. So we'll say right mouse button, include property, and then it adds that property to your list of material properties. So I'll click here on curve fitting. I'll say solve the curve fit, and then over here on the right, I can see how well we did on the curve fit, and I can fiddle around with that. I can try different models. Once I have the model I like, notice we're yellow here. That means we need data. So I'll say copy calculated values to property. So I'm going to use those material constants I just created with the curve fit, and it fills those numbers in right here. And now we've got a complete set of material properties. So it's a very nice curve fitting capability. If you have your test data, then you got all of these different material models, and ANSYS will do the curve fit for you.